Hello and welcome back to our YouTube channel. So in this video we are going to find the derivative of exponential functions, and I'll show you the best way to approach it by deriving the relationship. So let us say when we mean exponential functions, we mean when we have something raised to a certain power. That is what we mean by exponential functions. In this case, our a is an element of real numbers, okay? And you have to know this property in mathematics, that when you take natural logarithms of a to the n, that is equals to n, the natural logarithm of a. That with logarithms you can bring down your power down. So that is what we are just going to apply here to bring our x down. So we'll take natural logarithms on both sides. So if we take it here, we just get natural logarithms of y equals to natural logarithms of a to the x. And if you apply this, you can now bring down our x down. So we get natural logarithm of y equals to x natural logarithm of a. And from this, what I'm going to do, I'm going to find the derivatives of both sides. That is how we differentiate this with respect to x. So if you differentiate ln y, remember, if you differentiate ln x, the derivative of all of this, we just get 1 over x. That is our derivative of ln u is equals to u prime on u. Okay, so the u prime here is, our u is x, so it will just be derivative of x is 1 and divided with the u, which is x. So that is what we get. And if you come here, you take now the derivative of ln y, you just simply get 1 on y, but you attach your dy on dx. Each time you differentiate y, you attach your dy dx. And we have always been doing it. Don't think that it's just now. Remember, if you had y equals to 2x, then if I differentiate this, I'll just simply get 1. That is the derivative of 1 for y is just 1. Then I'll attach my dy on dx. Then if I differentiate this, I just get 2. Have you seen that? So here, when we differentiate ln y, we just simply get 1 on y, and that will be equal to, if I differentiate x ln a, I just get the derivative of x is just 1, then I just get ln a. Have you seen that? And we now get dy on dx to be equal to y ln a. That is, I will just cross multiply like this. Right? You see, now we just get dy on dx equals to y ln a. I've just multiplied both sides by y. This y cancels and we get dy dx equals to that. But what was our y? Our y was equal to a to the x. So we go ahead and replace that. So our dy on dx will be equals to a to the x ln a. Have you seen that? Okay, now when we reach at this is my target. This is where we wanted to reach. So if we reach, let us make some small assumptions. Let us say, what if a equals e is Euler's number, which is equals 2.71 something. If a equals that, what will now be our differentiation? We will now get dy on dx. If a equals to that, let me first start by putting y will now be equals to not more a to the x, y will now be equals to e to the x. And you come down here and you substitute, you just simply get dy on dx to be equals to e to the x, that is our y here, that is our y here, which is e to the x ln a, and our a is simply of e. And remember, ln is natural log to the base of 1 to the base of e, sorry, to the base of e, and ln e base e equals 1. So dy on dx will still be equals to e to the x multiplied by 1, or dy on dx will just be equals to e to the x. So if your y is equals to e to the x, then your derivative is still e to the x. Have you seen that before? So there are sometimes you will find this a lot in mathematics, and this is how we prove it. Hope you have learned something. But let us make a good example. Go ahead now and take an example. Now if you have y equals to x raised to the sine x, how are you going to find the derivative? So we'll just simply apply our logarithms on both sides to bring down sine x on the bottom. So ln of x raised to the sine x, and this will simply give you ln of y to be equal to sine x natural logarithm of x. And we have just gotten what we got last time with the a to the x. Now I'll differentiate both sides. If I differentiate ln y, I just simply get 1 on y. But don't forget, if I differentiate y, I just simply get 1 on y, dy on dx, always attached to it. And if we come now to differentiate this, we'll use product rule. And to apply product rule, so let our u to be equal to sine x and our v to be equal to ln x. And our u prime our derivative of u, that is du on dx, our du dx will now be equals to cos x. Recall we did the proof. And our dv on dx will now be equals to 1 over x. So with product rule, you take u times dv dx plus, that is, we will not do u v prime plus v u prime. So that is what we are going to apply product rule. And product rule says to differentiate these two functions. That's an easy way to do it. So our u is simply, I'll use white for u and to the first term. So u is simply sine x, so we write this sine x. All that multiplied with our v prime, which is simply 1 over x, plus our v, which is simply x, and our u prime, which is simply cos x. And that's our derivative. But what are we looking for? Dy dx, not 1 on y dy dx. So we can now cross multiply. So we just get our dy. I can write the formula down here. So we get our dy on dx. I'll cross this y on, so to be y into, I can write 1 on x first, then sine x. This one I can write 1 on x first, sine x, plus ln x, all that multiplied by cos x. But recall we have a value for y. We said that from the beginning that y equals to x to the sine x. So our dy on dx will finally be x raised to the sine x, all into 1 on x sine of x plus the natural logarithm of x, all that is being multiplied by cos x. Then we close our bracket. If you like, you can open the bracket. If you like, you can allow like that, but the best way is to allow it like this. So this is how to find the derivatives of exponential functions. Can you go ahead and give this video a like, and make sure you subscribe to the YouTube channel, share to your friends, and thanks for watching, and have a great day.